Hey, good morning, everyone, and welcome to Technical Toolboxes webinar, Evolving Pipeline Engineering Calculations Beyond Spreadsheets, Automation, AI, and more. We will be led today by our in-house expert of all things pipeline related, Joe Pikas, along with Febin Joes, our TT's own Director of Product. My name is Kesley Price, and I am the Product Marketing Manager here at TT, and I'll be facilitating the webinar today. So we will get started here very quickly, but first a couple logistical details I need to cover. If you have any questions on what we're covering, there is a chat box or questions tab at the top right of the screen of your webinar interface. Please send us any questions you may have throughout the entire webinar, and then we will also cover those at the end during our live Q&A. If they pertain to what we're actually covering in the moment, I will stop the presenters and we can cover it then, or save it for the end for the live Q&A. We will send a copy of this webinar recording to everyone in attendance and all of our registrants via email within the next couple of days, and we will also have this available on our YouTube channel. So, changing it up a bit today, we're going to go through the agenda here real quick, and then we will have a poll question here. So, what we're covering today, Febin, if you wouldn't mind, they're showing the, okay, there we go. So, changing it up a bit today, we wanted to have a poll question here at the beginning of the webinar to see where our audience stands. So here we have, what's your biggest pipeline engineering challenge today? If you end up selecting other, this could be something like onboarding new engineers or
Kesley,
finding. Yes,
I
sir.
don't see it. I don't see
The poll question is up right now, Joe. No
oh,
worries.
oh, I'm sorry.
No one
That's
cares.
all right. That's all right. So they'll have about 30 more seconds to answer this poll question. So if you do select other, we would love for you to give us the answer via the chat box on what that actually means for you and how you define that. It could be onboarding new engineers or finding time to verify third-party projects, whatever that may be. We'd love to hear from you. And that gives us some help on the direction of where we're going in this webinar today. So as soon as this poll question wraps, I'll just walk through the agenda real quick and then turn it over to Joe and Febin to kick it off. All right, so first we just did introductions. Joe and Febin are first going to tag team the evolution of pipeline engineering calculations. And then Joe's going to explain the full pipeline engineering workflow. And then Febin will showcase some of our new enhancements that we've done to the Pipeline Toolbox and others within the Pipeline Hub and what's coming down the pipe for technical toolboxes and how we are taking your feedback and turning that into enhancements and making your engineering workflow easier day by day. And then we'll end with the Q&A. All right, Joe, I will turn it over to you, sir.
Okay. Look at the poll question. We need to move ahead. There we go. Okay, evolution of pipeline engineering calculations. This is one of my favorite slides, particularly this stone tablet. Okay. Just want to give you a little history about this stone tablet. The Romans used these back in 132 BC. Why? To build their highways and roads and systems back in those days. Could you believe it? And in fact, the same contract language and some of the techniques of building roads, they even had transits without even without telescopes. They just went back 100 feet and lined up 5 plumb bobs, and that's the way they did, did their alignments. But this is the kind of stuff, and you could read this stuff all these years. And what do we have? Pen and paper. Think about it. Manual calcs, time consuming, phone to human error. Yeah, and difficult to validate sometimes. And when I look at this, have we evolved from 132 BC to today? I hope so. And then along comes spreadsheets, right? Uh, whether it was back in the day, Lotus 123, or what we're using today, Excel and other types of spreadsheets. And these are the kind of things we need to think about. However, they're limited. Sometimes, and they're usually local to the particular uh, PC that you're dealing with. And we get into what happens when we get into trying to analyze ILI data when we got tens and 20,000 or 30,000 types of anomalies to analyze. It's not going to be done right. So we got inconsistent logic, no version control, vulnerable errors, and painful to share or scale, and slow in many cases. So these are the kind of things. Even though we've gone digital, we really haven't progressed as much as we need to move forward. And then here's the one of all: easy to manipulate. You know, we work in silos sometimes. You know, disconnected workflows. It's not integrated. This is the key. And this is what technical toolboxes is working on. Febin's going to talk about this in a second. You know, point solutions, you know, plus silo teams, repetitive data entry, and this is painful. And instead of a risk of and then misalignment and things of this nature, because spreadsheets could be changed very easily. And then, of course, by the time it gets out to where it needs to go, it's very slow decision making. And Febin, I'll let you pick up the other two, where we're going to move ahead.
Thank you, Joe. It's been interesting to see the evolution so far. So what I want to focus on is the last two pieces there. We as a team, I mean, we collectively made the decision to move to cloud, and the reason was we want 100% access for all the users at any given time, and cloud is the best way to do that. But as we evolved, our thinking for what a cloud-based architecture has to be rethought, because we don't want to essentially just make the solution available in cloud. We want it to be something that is easy to collaborate and has a centralized data structure. So what I meant by centralized data structure: as a team, you have multiple engineers simultaneously working uh, in the application. So you need a centralized data structure from where the common data can flow across the team. And that is one of the most important things the cloud can provide. In addition, I mean, think of S-ray mapping service, the ArcGIS system, where you have your asset data with the UPDM ports data that has your attributes that can be utilized across the calculations that you're doing. These are all factors that essentially do two aspects for it. One is basically allowing you to make sure the data that you're using for your calculation is validated and kosher. The second thing is seamless reusage of the data. You don't have to essentially have your pipe characteristics and the operational characteristics of your asset data entered multiple times as you're doing your calculation process. It should be as seamless. And those are the kind of things that we essentially figured out as part of our cloud fast strategy. But still, it wasn't near perfect, as you know. I mean, anything and everything happens through what we call as the evolutionary stage. And one of the shortcomings that we had in this case was uh, how can we automate some of the mundane tasks that you're doing? Uh, how can we essentially help the engineers be more efficient and more use the time that's allocated for more important work and help automate some of those stuff? And that includes features like batch run, where you can essentially enhance your calculation process. If the same model that's working, you can essentially do that. And you know, with a cloud architecture, it's a scalable architecture, and one of the things that it can essentially help is it can essentially help scale up or scale down the performance requirements for you. And those are the kind of things that we faced as shortcomings initially as we came into it. Now, if you look at how we are evolving, we are reaching a state where artificial intelligence is essentially going to help us to be more efficient than how we were. And it's more about how to meaningfully use the power of AI so that that can essentially help you do your work in an effective and a broader manner. And that's essentially where the full life cycle engineering features comes into the picture, where, hey, you want the AI models to essentially work with you so that, I mean, the information gathering becomes much more faster. If you look at the evolution here, that instead of in terms of information gathering, initially it was you essentially looking at the physical documentations and the physical books to essentially figure out what those information were that you were to gather. Then the digital copies came in. Then the idea of essentially scanning the docs and just referencing the docs came in. Now we are at a stage where essentially we can use these documentations to essentially give you answers that are not just blatant copying sections of the documentation. It's more about, from a reasoning standpoint, helping you interpret what those sections mean. And those are the kind of things that we want to do with the AI powered engineering, with the full intent of essentially helping you simultaneously work on multiple projects, making sure you're fully compliant, making sure that, I mean, your documentations are TVC compliant and are also regulatory compliant. So that is our evolutionary phase that we are in, and I can't be more excited to show you some of this work that we are doing, and you will see more of that in the next slides as we are presenting it. So what we're going to do next is I'm going to move to the next slide where Joe has some wholesome slide talking about the full capabilities of Pipeline Toolbox solution. Joe, I'm going to move to the next slide. Here you go, Joe. Joe, you might have to unmute yourself. I can't hear you.
Picture this. We have a map over here, and your boss comes in, or director comes in, whoever, and says, "Can you give me could you have an estimate ready for me by lunchtime?" Okay, and we're gonna build a 10-mile pipeline from a gas well to an existing pipeline that that exists near a compressor station. You're going to tie into that, and I need that estimate so we could discuss it at lunchtime. Well, what would you do in something like that? And you only have and the only information you have is the upstream pressure at the gas well, and you have to decide, number one, what's going to be my pipe diameter, what's going to be the wall thickness. You could see through the map that I have several road crossings and things of this nature. I have to do. It's a gas line, obviously. Uh, there's class 1, 2, and 3, but why would you do a 2 when eventually it'll be a 3? So you got to think about those kind of things. Less different wall thicknesses, less issues. You have to do a pressure reduction, uh, uh, and 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 it's very mountainous in this area, as you could see. Um, we need blocks, pipe bending, hot dap. We even have some flooding areas, recent flood areas in the creeks and stuff like that. Uh, we need to calculate, uh, are we going to go HDD or can we do an HDD? And then of course open cut and so on and so forth. Can we really do that before lunchtime? We're still thinking about all that lunchtime stuff. And then what about, this is just part of the design. Now we're not going to include. We're going to do a design. We'll talk about a meter state regulator and meter station. But what about the existing uh, and foreign line crossings. Landowner imposed limits for pipe transport, water and trucks, and the blowdowns and purging and HDD crossings. Can we put all that together too? That's all part of it. Technical toolbox is pipeline, the pipeline hub with the toolbox can do all of that. It's pretty easy. We have over between the liquid and a gas, we have over 250 calculations. And then in the design and stress analysis, there's over 18 calculations that will cover most of these requirements up here in the first one on your pipe specification. Now we're not going to do any, we're not going to determine the clearing, ditching, but the other stuff we could do, the water crossings and so on and so forth. And even we need to think about hydrostatic testing and so on and so forth, and 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 even CP and commissioning. We could even do a quick calculation to determine because we want to have a separate system not tying into the main lines uh, because it'll go through a regulator station and meter station. So, so can we really do all of this? We have sections where you could do blowdowns. You've seen them. Have you really looked closely at at your pipeline toolbox and it's consisting of modules? They're the main ones, like design and stress. We got crossings, and crossings are simply the fact that can you run your equipment over existing lines and foreign lines? Okay. Can we come up with the hydraulics to determine the downstream pressure that we need and the flow rates and size the pipe? Very easy to do. Let's see. You could be done. In fact, you could be done before lunchtime. And with what Febin talked about, even with all the reports and including the AI information too. What will allow you what what you can do and you're allowed to do because it's tied into the regulations. It's tied into ASME B31.8, B31.4, or API. You have all that information at your fingertips. We have all the calculations to do cathodic protection. How many anodes do we need? Isn't that amazing? It's just it's it's awesome, when you could go down there. And then the landowner is going to impose weights because you're going to have to move pipe across his property. Okay? He has some of these little bridges, across his property. How many joints of pipe can I transport at a time? You got the weights, it's pretty easy to calculate. How about when we're ready to run hydrostatic tests for water? Maybe we have to move water. Maybe we don't. Maybe we're slick enough to figure it out, from the creeks and how to break it up correctly. How about the blowdowns? When we're going to do tie-ins and things of this nature, and the purging and so on and so forth. And then the best one of all is an HDD crossing. How many do we have? In this case, they may have three, and they're going to be very unusual because they're going up mountainsides. They're going to come around. So maybe some of these have to be open cut, and that's what you have to decide, which way it's going to go. And those decisions, you could come up with a quick decision on some of this stuff. You don't have to get it perfect. In this case, this particular line turned out to be a 12 and 12.75 line, and there was 3 areas where there was class threes. Okay, that needed we needed pipe for that, and so you could easily determine how much pipe you need. Both class 1 and class 3 by getting a quick estimate. So it turned out to be a 10-mile pipeline. We have to regulate, right? So we have a regulator and meter station application, and then we have to tie it in to existing pipeline. And what do we have there? Thermal analysis, the PRCI program to do your welding and things of this nature. You could take a look at that. We're going to need certain things here. You could get an estimate on that, and also a program, to do the tie-in itself. So these are the kind of things that we have. But lo and behold, somebody throws a monkey wrench into the whole thing and says, you know what? We could only use X42. That's all that's available. Pipe. And then on top of it, the pipe that you get, they tell you, has been in storage for a long time. And they found some metal loss on it and some gouges. So we have to run some calculations on this too. Oh my gosh, can we use this pipe? These are the kind of curveballs sometimes we're thrown when we're in construction. And that's why I bring this up. So whether the pipe comes in damaged or whether it was damaged during construction, right? We have all the tools in the toolbox for this purpose. And this is what makes it unique. And we definitely have to have a separate CP because we don't want it tied into the mainline system. We want it tied away from the station. You have to think about that where that tie-in would be the best place, and so on and so forth. And these are bidirectional stations; they could pump either way. So no matter where, you have to make those kind of decisions. And then we could run AI literally on a daily analysis on all our calcs when changes come up. And this is where we could take the design, we could make it operational, we can make it project specific, and then on a day-to-day analysis, as we're improving and adding the how could I say it, intelligence or the IQ to beefing up this artificial intelligence. Remember, it's in its infancy. Okay, we have to grow it properly. AI, it's growing up, and we're adding that intelligence, but it's going to help you when you run your calculations. Why is this failing? What why did this pass? And the reasons why. It'll spell them out for you in reports and things of this nature, which Febin will talk about later. And and we want to still meet the ASME and PHMSA industry standards. I call them standards. They work together. The regulators really don't want all these regulations. They're basically still based on industry standards, and that's what we need to be working for. So this is where these tools come in to be handy. Whether you're on the design side, whether you're on the day-to-day uh, 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 operations, and then on the integrity side, specifically, how am I going to handle this metal loss? Can I use the same pipe to put in? We found out too late about it. We had this is what it is. Is it adequate to meet and to be a pristine pipe? What needs to be done to it, and so on and so forth. So this is why I bring this up. And Febin will take it from this point on and tell you how we're moving forward and getting this AI up to where it needs to be for your use whether it's on a design, operational, integrity related, and also for determining a full life cycle on these pipes. Febin?
Thank you, Joe. Let's first go to the next slide. All right. So Joe has given a very good overview on what Pipeline Toolbox's solution can do, right? And if you remember, we essentially showed everybody what the evolution of the tool looked like. Now we were in the CloudFest application, and we were like, okay, fine. What are the next things we could do to enhance the products that would help facilitate efficient use of the tool? And these are some of the new enhancements that we rolled out. So on the left, what you see is what we call as Piper Insights, right? So what Piper is our specialized AI assistant that we developed for the pipeline engineers. So there's a lot of commercial models that are in the market, but what we wanted to essentially do was we wanted to essentially approach it from a pipeline industry first standpoint, and that's essentially what we did. We trained the model against detailed uh, technical sheets, technical reference documentation from the industry standards and the regulatory documentations that helps build conformity in the answers that Piper is answering to our customers as they're answering it. So we trained it against we trained it against the handbooks, the reference documentations, the regulatory compliance, everything that needs to be known so that the answers or the insights that the model is giving are very contextualized. Now, what we also did was, we essentially made sure it understands the different demand that we are putting it across with. In Pipeline Toolbox, we want to make sure, it understands the design, the stress analysis, the construction, the integrity management, and these different topics well as a model so that it can answer those questions that's tied to that. I'm going to show you more examples of what it means from a real demo standpoint, but that's what we did. Now, that's our AI large language model that we developed. That's what we call as a Piper. Now, once Piper has all this information, the next thing that we can do is essentially make sure the Piper model is integrated with the calculations that you're performing so that the calculations can be used as a context to help summarize what the calculation is about or what the calculation analysis was all about, what the results mean, what it means under the reference context. So think of it as a co-pilot of yours that's essentially working simultaneously as you're running the most important thing, analyzing the calculations, looking at the calculation inputs, gathering the input data, looking at the output, and somebody summarizing what the output means from the context of the regulatory standpoint and the compliance standpoint for you simultaneously. That's what Pipeline Insight does for it. And what we have done, like Joe alluded to, we are in the very early innings. We want to move slow, make sure we are 100% confident in what we're doing it. So we have started rolling out Piper Insights, starting in the crossing module, and we want to just expand it to other modules within the Pipeline Toolbox. So that is related to the AI side of the story, right? Now, like we said, when we moved to cloud, the cloud movement was about centralization, so that central access happens. But at the same time, the efficiency side of the problem was still there. And when we spoke to a lot of our engineers, one of the things that they said was more so around how can I efficiently run a calculation, making sure my time is properly invested in understanding the calculation and understanding the implications of the calculated results and the input over a range of governing ranges for the operational conditions. And so what we did was we essentially went back to the drawing board. We started building solutions that catered to that. And the two most important ones that came in from the advanced calculations built up within the hub platform, that's our platform, was what you call as the batch run capability and the sensitivity analysis. So batch run, think of it this way. I mean, you are doing a stress analysis module calculation or a pipe span calculation within the stress analysis. The model remains the same, but you as an engineer are tasked with doing the analysis for multiple different sections. So what you can do is, I mean, historically what you do is, I mean, you do a one-off approach where you run the calculation one time, look at the inputs, look at the output, interpret the results, and then go to the next one. And what we did was, hey, I mean, if the model remains the same, what we can do is we can essentially help facilitate multiple executions of the same model in one single go. And that's what the batch run does, and that's what it does for us. So we have done the batch run in models and modules where users are using the same module but doing a bunch of analysis for the same module. And we have the capability within the hub platform to handle that as we speak right now. Now, when you look at sensitivity analysis, what sensitivity analysis means is it has to be meaningful on how the calculation is analyzed. So what I called as a one-off analysis when you basically use your input to derive a conclusion for the results based on the inputs that you defined. But as an engineer, you know it better than me. What you are also looking for is you want to essentially look at the model and look at a range of input to see how your calculation is performing against a pass-fail criteria for that particular range. And that's what the sensitivity analysis does for you. You can define what those parameters that affect your calculation the most from your interpretation and how it's going to impact your pass-fail criteria. You can complete a study against the parameters that you're selecting, against the range that you're selecting, so that you have a better gauge of how your calculations is being set up. What are the results? What are the ranges that you have to make sure your calculation is range bound to? All those things in an effective manner. So those are some new enhancements that we rolled out. Now I'm going to take the liberty to share my screen and show you some of these features in action. Okay, so here's my screen, and this is live hub platform in action here. So you are in Pipeline Toolbox and you have Pipeline Toolbox gas and liquid here. Now, for this particular session, what I have done is I have gone into Pipeline Toolbox. I've taken the crossing solution, and I'm interested in API 102 pipeline crossing highway analysis here. As you can see, this is a calculation that I'm looking at. And these are my calculation inputs and my results here. As you can see from the results, my girth world is failing in this particular unique scenario. And me as an engineer, I want to analyze, I want to figure out what could be the cause and how I could better understand the context of girth world from an API 102 standpoint. So what you see on the right is Piper simultaneously running and analyzing your results and being your perfect co-pilot and helping you understand what the results mean, what the analysis of the results look like, what are the implications of the results, what the failure analysis means, so that you can understand what those parameters are that's affecting your output results from an API 102 standard. And it's going to help you step by step in your way to help figure out the problems that you're encountering. I mean, if it's a case that's passing, it gives you a summarization of what your results mean. In this case, since the case is failing, that's why it's doing a failure analysis for you. Now, it doesn't stop there. What you see here is it can essentially even do a study for you. That's when the sensitivity analysis comes into the picture. It can help build a sensitivity analysis study, look at the parameters that are impacting your calculation the most, help build a decision matrix to essentially gauge those parameters that you want to study. You can then select the parameters of those that are interesting for you to define, hey, what is my minimum and maximum range that I want to study this parameter against. It gives you a case summary, help you understand the study from a study metrics that you have here. It's a heat map that essentially has a pass-fail criteria that's built in for you, that where you can select any two parameters at a given time between your input and the output axis, so that it can essentially help analyze that for you. And it can give you that broad range here. In this case, we are doing an analysis of we load from single axle and the operating pressure to essentially help understand what is the range bound that I want to study this model against and what it means. Now, what you can even do further is you can even select one of those parameters and essentially be like, hey, I want to see the impact of this parameter on what my effective stress is and what's my safe range that I want to stick with. And that's essentially what you're trying to do with the study plot here. I have multiple examples here, and these are things that you can essentially do as you're doing a single analysis to essentially build a complex analysis where you are safeguarding not just your interest of your company's interest by understanding the broad implications of what your analysis means, everything done in a cohesive, seamless execution standpoint. And what you can even do further is you can essentially take all the study details, the summarization, and build your unique report that's submission worthy, that's coming out of Hub as a platform here. So those are the things that we're talking about. That is all fully integrated within the Hub platform. And I'm showing it to you live as we speak in the Hub production platform here. So this is the AI integration and the AI insight era here. So we are not stopping. We started off with Pipeline Toolbox. We are now fully integrating the AI models within the pipeline crossings, and we want to start expanding on this. And that's where the roadmap comes into the picture. And in my next slide, I'm going to show you what our roadmap looks like. It's a good place where you can also give your feedback. And so let me just take you back to this slide and walk you through what the roadmap means for us. All right, we are back to the slides. So this is what our product roadmap looks like, and this is for Pipeline Toolbox. So what we have done effectively is we have spread across our core areas into 3 different sections. One is the platform. That's the Hub platform, where anything that's high level that's going to go into the platform integration, it goes into the platform roadmap for short term and long term. Pipeline Toolbox is our product, and Pipeline Toolbox has the calculations, the models, and anything and everything that you want that could get integrated there. And Piper, the third section, is our Piper model that has a short-term and a long-term perspective on what the roadmap would look like. So I'm going to go bottom to top. From a Piper standpoint, right now, where we are, right? We started off very high level. We want a very good model that can essentially help the industry in the best possible way. So we wanted to train the model and benchmark the model to essentially figure out whether what we seem as helpful is helpful for our customers. That's where we win. And that's what we kind of achieved with the Piper model. Right now we have a solid model that can help explain contextually on any questions that you ask from the Pipeline Toolbox standpoint. What we also wanted to make sure was, it's not a lightweight model that scrolls the internet to give you the answer. It has to be very research objective focused. look at the knowledge from the knowledge database that's available for him. That in this case, it's the reference documentations, the help documentations, the handbooks, and the and anything that's industry reference, and build insights and reasoning from that. So we accomplished that. Now, from a Piper Insights standpoint, we went into the insights. We wanted to essentially develop insights for the first module, and we are exiting this quarter with integration in the pipeline crossings, and we're going to start expanding it as we speak. Now, the next thing that we want to do, I mean, we are still very early. What we want to do is we want to essentially gather the insights that are being delivered from something like Piper for a particular case analysis to give you contextual sensitivity analysis models that relate to the parameters that the Piper is recommending as the parameters that have to be studied further. So that is still very early for us, but we want to expand it to that so that, I mean, your time is effectively utilized in essentially narrowing it down to what that actual problem is. We think, I mean, we are going to have uh, a, a full-blown integration on that front in Q2. So that's where we are. From a long-term standpoint, what you see here is where we want to go with Piper. And these are all the models where we are essentially going to combine with the Piper integration and the Piper model there. Now, from the tool standpoint, Pipeline Toolbox, we have been continuously rolling out improvements for Pipeline Toolbox. Our goal is simple. We want to be the best tool that the industry can use without a doubt in helping them do the day-to-day calculations and day-to-day models that are required for you to do your job effectively. Joe has mentioned all the different arcs in which, I mean, we are focused on from a Pipeline Toolbox standpoint. Our goal is to essentially gather feedback from our customers to see what are those missing parameters, missing calculations that are there. We take those calculations into account. We develop those calculation models, and we routinely evolve and add those calculations there. So what I show in the short term, most of it is done right now. We are currently working on pipe support calculations that could essentially help everyone in the industry. That's something new that's going to come in. And from a long-term standpoint, these are some of the calculation models and the updates that we think we want to essentially work Pipeline Toolbox to so that it's more comprehensive than where it is right now. The next and the final is the platform. From a platform standpoint, we are fully compliant with ASME B31.48 and CSA as we speak right now. CSA tables for the location class, the design factor, all those tables are fully integrated within the Hub platform right now. That was something that we were doing, and that's fully completed as we speak. The Plastic Pipe Institute has constant updates coming in for the plastic pipe, and those tables are derived from the handbook, and those are also integrated into the Hub platform for Pipeline Toolbox, and you can use that and see those tables updated in the Pipeline Toolbox row. If you essentially look at the polyethylene pipe module, you have those features enhanced and updated there. From a long-term standpoint, I mean, we still are very early on the CO2 models. We are essentially waiting on FEMSA to essentially update their standard for CO2 so that we can go ahead and fully implement it. We also want to look into more compliances on the emerging fluids, because emerging fuel is something that's where the industry is going. We want to make sure Pipeline Toolbox is also compliant and ready to essentially take full advantage of what is coming there. So that is essentially how our short-term versus long-term product roadmap looks like. And what I want to leave as for as in a place to essentially think further is short term is anything that we have absolute clarity in. As we get more clarity, those becomes our core execution points that we continue to execute. And long term are ideas that we essentially focus on, where as we get more requirements covered and more granularity in, we go full in and develop those as important product modules or enhancements to the product. And that's how, I mean, we work on a high level within the technical toolboxes product team. And it's a good segue. I am at the right time, and I'm going to invite Kesley back so that
Thank
Kesley
you,
can take
Febin.
us forward.
Yeah, absolutely. Joe, Febin, thank you both. We're getting some good questions from the attendees. So before we get to the Q&A portion and cover all your questions, we're going to cover one last poll question real quick. We'll display this for about 60 seconds. Obviously, as you saw in our presentation today, we are really focused on the Pipeline Toolbox, or PLTB as we love to refer to it. This app covers many, 250 plus to be exact, calculations across all areas of pipeline engineering and those workflows involved with that. Your response here helps us know what to prioritize next in our product enhancements, kind of like Febin showed. That's all based on user feedback, and where we can best serve you moving forward. So by filling this out, you're really helping us and helping you in the long run so that we can continue to develop our product to best serve you and your company and your upcoming projects. So we'll give this a few more seconds and then we'll move on to the Q&A. So let me filter through these here. While this is wrapping up, Febin and Joe, I'm going to go ahead and start asking some of these questions that we've gotten in the questions chat over here. So the first one, Febin, I believe this is for you. Is Piper a fork of any other widely available GPT, or is this a fully in-house developed by TT? Was the first question.
That's a good question. There are two aspects to it, right? There is the model that's being utilized, and then there is the training element that's there. So the industry has few benchmark models, and ours is the OpenAI model, but that's how the model is trained on reasoning and interpretation capability. What we have done is we have used that model to build our version of it to essentially help answer the questions based on the unique database of information that we have used. So a good way to essentially look at that is the large language model is a commercial piece right now. It's about what the bucket of database and what the bucket of documentations that it has that makes it the differentiating factor. And that is where we are essentially doing it. We have essentially developed our own database of documentations, reference conditions, reference help guides, everything that's used as the sourcing material for the model to actually answer the questions. So that's how we have built it.
Great, thank you. Next question. I want to know one more thing, whether your toolbox is validated or vetted by API, ASME, CSA code, standards, etc., so that the result of the toolboxes can be accepted by regulatory body or rather than certified by the regulatory body. So kind of a statement, kind of a question. Did you get that, Febin?
Absolutely, I get it. But this is more of a joke question. But what I can tell you is, if you go into the DOT documentations, and if you even go to the API 102 documentations, DOT recommends Technical Toolbox as a licensed vendor to essentially use the crossing calculations, which means they have validated it to essentially prove that. But Joe, you have much more interpretations and knowledge of this compared to me.
Yeah,
Why don't you go first?
the best way to answer this is we have all of the standards, that it's linked to. It's similar to like what PHMSA has, with their regulations, um, and there's always um, a little bit their minimum design. So keep that in mind, and and it's really so whether you're dealing with the regulations themselves or ASME or API or NACE or AMP or any of these, they're usually minimum design. And um, and if you look at the way things are done, example would be like design. You're going to design a pipeline. Uh, I mentioned that you have a class 2 in there, but you're not going to buy class 2 pipe. You're going to buy class 3 because within a couple of years it'll be a class 3. So that's a hard question to answer in many ways. Does it meet? Uh, it's really up to the uh, PE that's in charge of his design or her design, to validate. And all we're showing is you meet these requirements. And if you looked at uh, the artificial intelligence and the AI, it says you have to meet this requirement. However, uh, uh, you exceeded it or you're under it, and what our whole purpose is to point out those areas of concern. Do I meet it or I don't meet it, and how much am I over? Uh, Example is some things are Europeans use a lot of corrosion allowances, in their design. I don't hear that word today as much as I did years ago, because the pipelines were lower stress, so they had to be heavier wall thickness. So there was an almost built-in corrosion allowance years ago when engineers designed pipelines. Today, we could design a pipe. We're trying to save money on weight, for transporting, the pipes to and from, the places, from the mill to the work site and so on and so forth. We want the extra strength in it, for damage if the pipe gets hit. But I never hear the word corrosion allowance anymore. And I even wrote a paper on some of this stuff. I compared X35 to X70 pipe. In every case, the X70 has the same corrosion rate as the X35. And guess what? The X70 for metal loss had when when the coatings failed or the CP failed or a combination of things had to be repaired. So that's a tough question to answer. Does it meet? Uh, and does it stay that way? And is it maintained that way? And so on and so forth. So so my answer is it meets the minimum requirements that are laid out by industry.
Perfect. Thank you, Joe. I'm sure that gives some clarity there. Febin, this is a quick one we should be able to answer so that we can move on to some of these others. Does the module run on all windows or does it have some restrictions?
That's an easy one, Kesley. So we are cloud first. So like it should, if it's browsers, we support all the browsers. We do recommend uh, Chrome as the preferred, but you can use Edge, you can use other browsers too. But since we are cloud first, I mean the browsers are what matters. I mean you basically have a URL, you log into us, and we are hosted in Azure, so that's a reputable cloud vendor provider.
Great. So the next one is kind of a tag on to one of the first questions we covered regarding Piper and is it, a chat GPT or built within TT. So this is a tag on here. We get this quite a lot, so I think it's important to cover this. Can you shed some light on how TT plans to handle confidential customer data when using a mainstream language model like Piper?
So for customer data, we have a very binded customer data policy, retention data policy, and the data that's being used, there are two aspects to it. The cloud-based solution. So when you are in the cloud solution, I mean, you have a unique ID in which the cases are created. We even go to further depth to essentially help you define how you want to collaborate with your colleagues. So when you go deeper, you have a company admin within the hub platform who essentially is the enabler to essentially enable if you can talk within your company too. So we have a fully documented data retention policy and compliance policy that we agree to, and we maintain it, and that is as part of our software service agreement that we have. For the AI integration and the AI model thing, we don't the AI model interactions is session based. So what it means is the information that it's gathering, it's very siloed. It's not scrolling the internet to essentially gather the information for you. It's session based. You are interacting with the model in that particular session where your information is being spoken with the model, and the model retains it for that particular session. So if you currently look at it, we don't even maintain a history of your interaction, simply because we want to essentially help facilitate that session based user activity as you interact with Piper. So when you log out and come back, and Piper also, that's our AI model, it also has a new session where it's interacting for that particular instance and doing it. So that's been our policy so far, and that's what we're going to maintain moving forward.
Thank you, Febin. Okay, a couple more here. For those that we are not able to cover, we'll probably have time to cover one more question before we wrap. But for those that we're not able to cover live today, please know that we will follow up with you via email after the webinar by the end of the week to answer those questions we're not able to get to. We have gotten asked quite a bit, and we do every webinar. We will share this recording via email after the webinar, and it will also be available on our YouTube. So another question for both of you probably, how long does it take to get set up with Pipeline Toolbox? And kind of a follow-up to that, can it connect to our internal data systems, or do we have to import and export files manually? Evan, you want to take that one?
Kesley, I can. You just have to repeat that question. I might have
Yeah,
missed
no
it.
problem. So there was kind of two parts to that question. So how long does it take to get set up with Pipeline Toolbox? And can it connect to our internal data system, or do we have to manually import and export files?
Good question. So to get a customer onboarded, so the usual policy is you uh, you have an agreement with us, and it's as simple as, I mean, you registering to the Hub platform. We at the back end integrating a unique licensing to your account, and then you're good to go. You can start. I mean, it can be as simple as uh, everything can be done in 5 to 10 minutes. All you have to do is just register, and we approve. And as long as you have a license, you can do it. Or it can take anywhere from 10 minutes to 30 minutes. But the other aspect of onboarding is, I want to go into it a little bit, is uh, it's not like a commercial software. We also take pride in making sure the onboarding is as seamless and fully compliant with what you can take what you can take use of the software. So we have a customer onboarding session that we usually have, where our customer service team sets up the call, walk you through the different capabilities of the solution, so that by the end of it, I mean, you want to make sure, I mean, you are taking full advantage of what the solution is. And that is something that happens parallelly, depending on your availability. I mean, we usually take a 30 minutes to simply onboard that. But to get you started, it can be 5 to 10 minutes to get you started. Now, the second part of the question is on data integration. So we have a ArcGIS system that's integrated with UPDM and ports. What you have to do is, if you have a GDB file, your company admin can import those GDB files into our system, so that it's a one-time import, then it's made available, and you can essentially collaborate it and use it. We don't do direct API integration as we speak right now, but that's on our roadmap for the future release.
Great. And I know there's more questions coming in, and I apologize, we have to wrap, but thank you all for submitting your questions. And for those that we didn't get to address live, we will follow up via email. I promise. We will send out the recording via email, as well as follow up with those that submitted questions that we couldn't get to. Special thanks to Joe and Febin, our presenters today, and to everyone in attendance. If you have additional questions or interest in something in particular that we covered today, especially as it relates to Pipeline Toolbox, and we weren't able to answer a question, we would love to set up some one-on-one time with you or your team. Please reach out to us. Our information is listed on the screen. But that's all we have today. Thank you so much, and we hope you have a great rest of your day.
Thank you, everyone.
Thanks, everyone. Thank you. You'll have a good day.